going to start with a very short introduction. So I guess about a month ago, Ivan, who's also here, and I wrote a blog post about a project to kind of get SciPy, scikit-learn, scikit-image as kind of three of the core projects in the SciPy ecosystem to go beyond like supporting just NumPy arrays. And this is an exercise that, many people over the past, 5 years, maybe even more, have worked on and off as volunteers on. So we kind of think we're now in a better place. We kind of accumulated a lot of the learnings from the past few years. And we've got serious use cases, as well as a sponsor in AMD who is interested in kind of basically get the hooks so that they can, implement support for their own hardware. And I think from an ecosystem perspective, that seems preferable to, continuing to build everything in little silos where, you need one package for one set of hardware, then you switch and you need a second package. So I think we have a real opportunity to do something useful here. There have been some discussions going on the new scientific-python.org discourse. Part of the challenge, I think, and why we thought about organizing this call is that it is a discussion and a design that spans multiple projects. That is, more complex than we typically work on in community-driven projects. And as a result, it's kind of hard to converge on, who makes the decisions, what are we going to do exactly, what's the introduction timeline, that kind of thing. And some of those threads went already in a lot of detail, I think, which is very hard to follow for a lot of people. I think it would be great to see here, people on this call, have expertise, but have mostly not been involved in putting together this proposal. So I would expect that they have, fairly critical and relevant questions, and hopefully that'll be a great resource and, help converge this conversation a little faster than if we only have async messages on a forum, because that's not the great way to, if you exclusively do that, that's not a great way to design something both robust and complex. I think that's about it as an intro, maybe, for me.
Yes, Stefan, did you want to add anything to the intro?
Yeah, I think that was good. The one other, so Ralph mentioned that groups want to have different array objects supported. The other use case that we discussed was where you have different implementations for a backend, and you might want to swap out various functions in the library, typically to get an accelerated performance. And I think some of the questions we have to answer today are, exactly, what is feasible, what's easy to do, what's hard, what's feasible, and what mechanisms do we need in the libraries to support overriding the functions and to allow array objects to pass through.
Okay, so yeah, does anyone have any questions to start this, or I'll call on someone? Okay, maybe Sebastian, you've
I see a hand raised by Stan.
Oh, you do? Where's the hands? Ah. Huh.
I can just start talking.
Yeah.
Sorry, I wasn't sure if we were supposed to use the raise hand thing or not, but
yeah, we were, but I don't know where mine's at. Sorry.
If you pull up the participant list, you'll see it.
Thanks.
And,
yes.
Well, I lowered it, but here, yeah, this is what it looks like. You'll see the name hand next to the microphone.
I see that. Thank you very much. Yep.
Anyway, so the question I had is what sort of does this proposal also, or how is this proposal addressing data conversion? So, for example, you have a GPU backend it would obviously want to operate on a GPU array. Is it the responsibility of the user to get their data into the start of whatever calculation they're doing in a GPU array, and then everyone will follow? What happens when you hit a library that doesn't have a GPU backend in the middle that gets an array on the GPU? It doesn't know how to compute. Error, conversion, error, and conversion. What are people's thoughts on that? So
let me start by saying, I think that should always error. We should never have silent conversions, especially device transfers, because they're really expensive. I don't think there's any array or tensor library that does this. Maybe TensorFlow here and there, but it leads to very hard to find performance issues. And in the end, I don't think that's what users want. Like if they feed in GPU arrays, they expect it to, run on a GPU and be fast. And if some piece of functionality is missing for some reason, either they can fix their code, or if it's really not implemented, I guess that's something you want to know and go fix.
And it seems reasonable. I just wanted to say it out loud so that we were, so there will need to be some amount of reasonable erroring to say when an array comes in and you cannot find a match to dispatch to.
Is there anyone who disagrees, who wants more auto conversions?
I mean, there's also conversions with warning. There's the conversion but not silent. But I think starting with errors is a reasonable starting place for me, I can imagine.
It's also, I think, the case that anyway, no other library will be able to do this conversion. Because, if you take, NumPy is kind of a little bit of an exception, but also it will not know what to do with a GPU array, right? It can't get anything from CuPy. But, CuPy arrays CuPy will just work on CuPy arrays, PyTorch will just work on PyTorch arrays, JAX will just work on JAX arrays, and so on. So you give it a foreign array type, like, it's not like it magically calls, its own as array conversion on it. So it will, even if you want it to do something reasonable, I don't think it will know how to.
So strictly typed dispatch, basically. No implicit conversions. That all makes sense.
I think that's hard. Sorry, I want to raise my hand first.
Please, go ahead.
Okay. The implicit conversions is hard to do both for developers and for users, especially as they mix that world. I don't know how you can guarantee static. Like for cuDF, we can kind of manipulate both those things, and we have this kind of social contract with the CUDA, this CAI, I think that's the acronym for the CUDA array interface, to not do things like forced synchronization or zero copy data conversion. But there is conversion there between those two object stores. And then when you mix in PyTorch, now you have, which is common in a lot of workflows we see. So we have workflows where you have PyTorch arrays and cuDF data frames and CuPy arrays, all kind of interoperating in a not strictly typed world where there's just a social contract between them. I'm not sure how things will break if you force a static type everywhere.
I'd say you can do conversions, but you normally do them explicitly, right? And there'll be zero copy data will stay on the same device, but you're not going to pass random array objects into a foreign array library, right?
You shouldn't. Yeah, that's true. But sorry, I might be getting confused or confusing the conversation, but with things like NEP 18, where you have dispatch, then you don't know what's going to happen. So if you can call NumPy functions on just these objects, and we expect like part of the world kind of looks like that right now. And with NEP35, which also part of the world looks like that as well, you do have developers that are trying to inform what the output type should look like based on the input type.
Yes, I think that is true. I'm not sure that's going to be completely relevant here unless we enable the NAP18, so it's dunder array function and dunder array ufunc within the array API standard. And I think it's also something that's extremely NumPy specific, right? Like it's dispatching on the NumPy API. And actually, when you do something like that, I actually would like it in the future to also be possible to make it symmetric, right? If we have a library that's now basically working only with PyTorch, right? Because that has its own growing ecosystem. How is that going to work with other array libraries? I think we're kind of past the point where everything is based on NumPy and all the others are newcomers.
So one thing there, I kind of can imagine that we do have a fallback implementation that is duck typed in some cases. If you can actually implement a library function only using the array namespace or the array function currently, then in principle we could have in theory we could have a fallback or an implementation that matches for any object which supports that API, which in practice I suppose won't be actually a lot of objects.
I'm looking for the raise hand thing. There was actually one maybe even higher level question that I was interested to get some of your opinions on. Because I think the majority of feedback we received was, went into like, hey, what should the design be? I think there was a question from Stefan Hoyer last week that I haven't responded to yet, who's like, well, do we actually want to do this? Is this useful? That surprised me a little bit. To me, it seemed kind of obvious, given all the work that has already been ongoing, that this is a good thing long term. But, given that he disagreed and, he typically knows what he's talking about, I'm actually curious if there's other people who are like, no, not sure, or thinking like, well, this is obviously not a great idea. Let's just not do it at all.
I assumed it was a great idea. I'm curious to see though. Yeah, I haven't read the Stefan's comment. I should look at that.
Stan's hand is up.
Oh, sorry, missed the button. Yes.
Stan, do you want to go ahead?
Yep. So yeah, I mean, having talked to a lot of the certainly from the hardware maker side, I mean, we've talked to a lot of hardware people, many on this call. And they're always trying to figure out how they show up with, in AMD's case also, which is why they assume they're funding this work. They show up and they have a faster version of some algorithm or several dozen of them out there for their hardware, and there is no obvious place for them to plug in. And so they're sort of forced down this decision tree of, and we've seen all these solutions. Copy the API into a newly named library and then force people to somehow depend on it instead of the standard, which creates wild dependency issues. Monkey have a package that when installed monkey patches an existing library. That's obviously fragile. That's referenced in the proposal. I don't think either of those solutions are good long term, and the problem only gets harder to solve the more hardware shows up. So, the Intel, AMD, NVIDIA might be the first most immediately engage people, but also you have the kind of not just hardware related things, but like JAX and PyTorch and other things that aren't hardware specific. But I think this problem will only get harder, and so I think the status quo is not sustainable. So whether that's not necessarily an endorsement of this proposal, although I think this is a good way to go. It's an endorsement that a proposal needs to exist.
Stefan?
Yeah, I think Ralph can correct me, but I thought Stefan was specifically talking about the array dispatching that gets quite difficult. And then the monkey patching. The concern I have with monkey patching is that you have a way to track what's happening, and there's no way to report that back to the user. So the system becomes completely opaque. If you get strange results, there's no way to inspect what's going on. So I think if we don't provide some mechanism for the functions to be overridden, then it will be done in all sorts of crazy ways that we have no control over. So I'd rather see some lightweight mechanism than nothing at all.
Stefan, your hand is stuck up. I don't know on my computer yet. Thanks.
Yeah, just to make sure that what I refer to is as like, I'm not sure how much we really need standardization with a tool like UArray for end user use cases. Just importing a separate library, for example, from jax.scipy import NDimage works fine and is nicely explicit. I think to me, it's, that's true if you're an end user and you just use scipy and scikit-learn. As soon as you use any other package that uses scipy, for example, that doesn't work. If you write a package on top of scipy or scikit-learn, that doesn't work. So explicit import switching, I think, to me is, that's what we've been doing for a few years, and it's getting harder and harder the more libraries and the more hardware shows up. So I just don't understand that. To me, that's not sustainable.
Yeah, go ahead. Ben or Benjamin?
So I want to say that I agree that we should do something here. I want to ask if this also includes libraries that are focused on multi-GPU libraries. So it seems like a lot of this discussion is mostly around a single GPU library. But if I'm designing for a multi-GPU library, a lot of the assumptions change quite a bit, where I can just import this library and things are expected to work across a cluster or many co-located devices.
So I think there's nothing specific in the whole design that it should be a single GPU. I think all the dispatching, you're talking about like 𝗗𝗏𝘃𝗃𝗃, for example, right? Or maybe also PDF.
Yes, 𝗗𝗏𝘃𝗃𝗃, so Dask using all these things somewhere in the middle, or like a future library.
Yeah, so I think in the dispatching case where you say like, hey, I feed an array, let's say 𝗗𝗏𝘃𝗃 array, for example, into a scipy function, and that scipy function dispatches back to, whatever understands 𝗗𝗏𝘃𝗃. I think semantics wise, like, you write the same code, right, as an end user. Like it shouldn't matter if data is located on a single or on 10 GPUs.
Stan?
Yeah, I was going to say, I think as long as the distributed, so a backend that has some kind of distributed or parallel execution, across multiple GPUs or a whole Dask cluster, seems like it should be okay as long as the entire distributed nature of it is encapsulated behind the backend. That, in some sense, the distributed array to the user looks, and to the dispatching system just looks like an object, and the distributed implementation of whatever on that distributed array just looks like a function call. there's going to be some limitations here where the fact that it is completely encapsulated behind the backend means that two different libraries may not be able to combine things in necessarily the most parallel efficient way. But it would be equivalent to if you just gave the end user an API and said, run these functions like you run NumPy, and it works on a distributed system. It's just to the library author, you're saying run these functions and it'll run distributed. Don't worry about the details. So I think for a number of use cases, it should be okay, and it should let people experiment with hopefully some creative backends, but it won't cover everything for sure.
Okay, so I take this to be like, it'll have limited support, maybe a good way to start testing things, but maybe is not as full-featured as, or as performant as what a distributed author might do. Yeah. Okay.
I guess so. Maybe to take Dask as an example, right? It adheres fairly closely to the NumPy API, but there's a couple of, once you start using it and you really start using like block size explicitly, for example, right? That's not a thing that is present in other APIs. For the array API standard, we've been careful to involve the Dask folks and to make sure to not include things like, median, for example. And so there's a bunch of like statistics functions. Median is excluded because, it doesn't really work on Dask. Like, I don't think it even implements it because it is too slow. So we've tried to be careful there to not put anything in, if we could avoid it, that would be inherently slow on distributed systems.
What about lazy systems? Does that matter here? Regardless of whether or not it's distributed?
Same, actually, because TensorFlow, Dask are both lazy. I guess lazy or, compiled to a graph that, often comes down to the same thing. And we've had some pain points there where, you just, they're not, a lazy or graph-based system is not as expressive as an eager API. But overall, we've also tried to design that you can implement the APIs in a lazy way. And that includes things like, trying not to return tuples or Python scalars, etc. But you can replace them with custom objects so you can keep things lazy. It's actually a complicated topic, so I'm sure there are other people who have other questions or opinions on this. But I would almost turn it around, right? It's like, say we have authors here of distributed libraries and of things with graph backends and so on. And I think that should be almost a constraint. And only when you get to a point where it's like, well, some whole feature completely doesn't work and I can't express it in any way that works in a lazy system, then, let's discuss it and clearly mark it as like, hey, this only works on an eager system. But there are not many features like that. You actually have to think pretty hard about examples of things that, that aren't implementable in a lazy way.
Yeah, go ahead, Benjamin.
Sorry, I have this might be very far field, but because I've experienced this pain for like 2 years, is there any CI/CD system in place that will be, or that you've thought about that AMD could put up for testing on their devices? I'm sure NVIDIA could send GPU somewhere, but to complain for like 10 seconds, like the claim that Dask could work with scipy objects was it was not laughable, but there was just any number of bugs that would come up, and you'd discover them out of band because there wasn't a CI system for testing on GPUs regularly. There is now, but it was a very painful experience for a few years to say these things work, and then a new developer would show up and change some bits of the code and find out of band that things were now broken. So going out and I think claiming or about to propose that things should interoperate with new devices. An ultimatum is perhaps too strong, but I'd strongly encourage us to write down ideas around having proper CI systems.
Public CI systems.
Yeah.
Yeah, I don't think anyone's going to disagree that the more CI and the more robust it will be. I think Stan, why don't you go first?
I was just going to say, honestly, this is a bigger problem than even this project. I mean, everyone who has tried to figure out how you're going to automate building, testing Apple Silicon anything is fighting this now because none of the traditional services have a public option. You can cross-compile, but then who knows if it works. And so everything like this, and then when you start talking about combinations of like, hey, I want to be able to run, this GPU or that GPU, or maybe even check if I can use, there's I guess we're talking about like a project hardware matrix. I don't know how we solve that, but it has. There are needs for it well past even this initiative for sure. So there's a lot of reason to talk about it. I don't know on this call necessarily, but definitely somewhere.
Yeah, to me, it's kind of more, every feature on every hardware that's supported should be tested somewhere. It's more like who's responsible for it, right? The way I'm seeing it today is like the actual hardware specific code that's not on CPU will not live in SciPy or in scikit-learn or in scikit-image. I think the maintainers have been pretty clear about that, and that's not going to be sustainable because they don't have the expertise. So the idea is that the dispatch layer, right, should be tested with mock backends in these projects. And then if there's a backend that implements, like, let's say for, AMD hardware or something, right? Those function calls, including, the dispatch should be tested, so that it actually runs in CI on real hardware, should be tested by the backend implementer. And I suspect that Dask is kind of a different case because that's not really I'm doing something on a different hardware, right? It claims it's kind of a meta array that takes in other arrays, but then it's only tested with NumPy, and it's like, it actually itself says like, I'm working with 𝗂𝗲𝘃𝗲𝗏, but this isn't really tested by either Dask or 𝗂𝗲𝘃𝗃. So it seems like the responsibility has gone missing there a little bit.
Oh, but one of the proposals is for UArray, which claims that it can dispatch to multiple backends. How do I know that that will actually work? Which for some reason feels different than the other, like NumPy, the NEPS that exist that kind of follow a similar trajectory.
I don't think it's different, and we haven't, we've had this in scipy.FFT for 2 years, and I can't remember a single case where that actually broke with like 𝗂𝗲𝘃𝗃𝗏FFT or PyFFTW or something. So I don't think it's different. I know Greg has actually been more involved than me in like writing scipy.FFT. Do you remember any case where it's like, well, we could have caught this with better testing?
I think it's been working fine. I mean, that module is pretty stable, so there's not a lot of API changes that require updates downstream. But yeah, I guess 𝗗𝗲𝘃𝗲𝗃 has that test for that integrated on their side, and yeah, so I guess the backend implementers are implementing the testing for these. But yeah, that's not a public solution for GPU-based testing, since that's on the 𝗗𝗲𝘃𝗲𝗃's own hardware, or the preferred networks hardware, I guess. But yeah.
Sebastian?
Yeah, to me also, it seems, I feel this is a library author's decision, but it seems to me the backend author is the one who has to do the testing. And the only thing that might be nice is to provide a way to run the original test suite using the new backend. If we can figure out a way to do that, that would be nice. But I'm not sure that it should be a blocker here for this whole thing. It seems more like a nice to have feature that would be good to work on.
I do like the idea though. So rather than, because what happens now is probably people copy the test suite at some point into the other library. And, from there on, it kind of diverges, making things more reusable. Seems like a nice to have. We can put on the roadmap somewhere.
Stan?
Yeah, I want to jump in on that. I really like the separation of concerns of the library that's dispatching to a backend has effectively like an acceptance test that says, if you pass these, if your backend passes these tests, then it should be okay. That every backend runs as part of their CI. So if you're SciPy or scikit-learn or something, you have a backend test suite that just, this is what I expect the backend to be able to do, that then everyone agrees on. And then when it gets updated, everyone can check, as opposed to that getting copied n times and mutating along the way into other projects.
Mike?
Yeah, one thought I have here that's along these lines, and I'm trying to figure out whether or not it's a faux pas or not these days, but I'm wondering, is there a way of defining this interface, or are there design patterns that could be defined here, or used existing ones to maybe define the API and the design around this from an abstract way? It seems like a lot of the approach in the thread has been more from a concrete standpoint. But is that a faux pas to ask for design patterns today? I know they've been overused in the past. Sorry, but
design patterns are just code that lots of people write over and over again. So I don't know if there's anything wrong with it.
Yeah. But it seems like that maybe, is that something that's missing? I'm curious as to why.
My French is maybe escaping me. Do you have a more concrete example of what you'd like to see? As in, well, design patterns sounds like a good idea to me.
A lot of what we're talking about with the backend sounds a bit like the strategy pattern, for example. If anybody's read the Gang 4 book, I can link to the pattern. But basically, it allows you. It has there's a standard interface, and there are multiple different strategies that can be swapped out. That sounds a lot like the backends that we have here. So you could have a strategy for each different backend, and then what's the granularity of that? Is it at the method level, or is it at the high-level object level, or the module level? But it helps kind of build some nomenclature from an abstract standpoint of these different interfaces that we're defining and implementing all these different libraries. And it kind of gets ahead of what stands after with the testing, right? We can then start to say things like, if this library or this module implements this interface and implements this standard design pattern that we're using, we can go and run the test now, right? And the tests are become more of a behavioral thing. Does that make sense?
Yeah, I think we kind of have that, but maybe we need to document it better?
I bet you do. I would definitely would bet that exists.
Stan?
So I just have an endless list of things. Sorry to keep spamming here. On that topic, actually, in testing, one tricky issue I know from the past that will come up and will continue to come up in that sort of behavioral acceptance testing is numerical precision questions. That it is, 150% certain that the backends will not get numerically bit identical answers, and that's okay. They wouldn't be able to do their job if they didn't. So one thing that will be a bit of a negotiation. I mean, because again, it's up to everyone implementing a backend interface to say what precision they expect backends to achieve, and not to just blithely just pick whatever single precision or double precision default is, but to be a little more thoughtful about what does my application actually need, because otherwise that can really constrain the backends on how they. I mean, so for example, if I'm going to say like I need, and I'm not thinking about it, and I say I need 10 to the minus 15 precision, I've just shut down a whole bunch of GPU optimization potential where you could get pretty high bandwidth for single precision if that had been acceptable. And so that's that kind of conversation we have to have happen a lot, is how precise do you actually want? Because people will sometimes just say, I want all of it. And then when you do that, there's actually not a lot of room for optimization.
Well, I don't know. This feels like part of something that isn't even a well-defined question within a single library. Like typically what we do when we test precisions in, let's say, scipy.ndimage, is, we define the test, we see where it fails, we compare with NP math or something as the exact answer. Maybe we have an analytical answer. It's going to be off by X on a given range of hardware. That's what we encode as the relative tolerance in the test. And then, well, someone ran it on, some ARM v7 hardware or something, and the test fails. What do? We just bump the precision a bit. So it seems to me like this is completely up to the backend. And like, if they want to be, 10x faster with a 3x loss in precision, they should write that in their docs. And then if the user enables that backend, that's the trade-off they get. I'm not sure it needs a more formal contract than that.
I think it's just recognizing and warning people that by doing this, we're going to make it more frequent that they have these conversations. Because they're going to have, hardware vendor X will go implement, something, and the precision will be good enough practically, but won't match up with their tests. They're now going to get bug reports from hardware backends that say, hey, I fail your acceptance test because do you really need that precision? And so upstream authors will need to be prepared to have that conversation with people downstream. And maybe they'll just say, no, I'm not going to change it. And then user operates at their own risk or something. But it's just recognizing that this is a category conversation that doesn't happen very often now, but will happen a lot more when you kind of open the floodgates.
Okay, I hadn't considered that, you would run the original test suite against the other backend and then something would fail. And then like, do you make the precisions pluggable or do you just bump the limit or what do you do there? Yeah, that I haven't thought about before. I don't know. Anyone else have thoughts on this?
I just think it sounds tricky if the precision changes a lot, and backends will have to be very clear about this because there could be funny side effects of changing backends. If this is assuming this is a backend in the sense that you swap out an algorithm and not in the sense of you write it for CuPy, because if just CuPy just gives always slightly less precise results, that seems much less of a problem than AMD or Intel writes a faster algorithm that gives less precise for NumPy arrays, where suddenly the behavior changes for the same input. So I think those two points are slightly different issues, and with precision changes, I suppose we just have to be very clear about if you enable this backend, things might get weird.
In a way, it's similar to something we recently did in NumPy, right? Where we enabled this SVML implementations. And then, like, you know, sometimes there were a few UOP off. And it's like, is that okay? Like, probably for 99.x% of the users. I don't know, it's a hard thing because we can document it. No one's going to read that documentation. So I'm not sure how we're going to do much better than, well, let's look at it with a few maintainers and decide it's okay or not.
Do you see the, oh, sorry.
Yeah, go ahead.
Okay. Do you see that the solutions being proposed? I'm having a little trouble separating like the things that we've done in NumPy and the things that are being proposed here for SciPy. Do you see a convergence of those two things? Like having these solutions kind of be pushed into NEPS as well?
That's a great question. Well, a couple of things to unpack there. First, about like NEPS, I guess Stefan and Jared have started coordinating this scientific-python.org forum with something called specs, which are basically like NEPS, but broader because NEPS were meant to be just for NumPy. And this is kind of across the, you know, scientific Python ecosystem. So yes, I expect we do write like a document like that or multiple. Then in terms of, is this along the lines of the NumPy dispatching? I would say yes, it's kind of broadening that, maybe with a different mechanism. But back as far as 2019, I guess, people, especially from your team, Ben, have been asking SciPy to kind of, can we enable this kind of dispatching for SciPy signal, scipy.ndimage, etc. And I think John Kirkham was the main person, you know, leading those discussions. The dispatch machinery in NumPy was never made public because it isn't quite a good fit to kind of copy paste straight onto a SciPy module. It really is a little NumPy specific. That's one. I think I had another thought that it just escaped me now. Let me think about that while other people may have opinions on this. But I would say, yes, it's along the same lines, but it broadens it to, you know, make it accessible to SciPy, scikits, and other, you know, array consuming libraries that want to start supporting NumPy and other array types.
Sebastian, you had your hand up?
Yeah, I was just thinking, so one thing that I keep repeating is that the NumPy dispatching only does type dispatching and doesn't allow actually backend selection as in a different computational backend, which is something array function just doesn't do. And I suppose once this takes off, NumPy could also consider adopting it. Honestly, I don't really see a huge reason why NumPy should not adopt this, assuming that this takes off. But I guess it's not the main target right now. I suppose we should not use array function outside of NumPy just because it's a bit, yeah, I don't know how well it will generalize. Also by the fact that everything in array function needs to be defined on the array object itself and things like that.
And just to be clear, I at least had not made any plans to propose that kind of dispatching for NumPy. I think for now we have array function, we have array ufunc. It seems to work well in the Rapids ecosystem. It's used there. Yeah, maybe long term, but I would, you know, I would think in the next couple of years that there's no need to kind of switch NumPy over for that reason.
Yeah, I would agree. Like let's wait how it takes off in SciPy and everywhere else, and if that's great, then we can think about NumPy.
Did that fully answer your question, Ben?
Yeah, thank you.
So there's a shifting gears a little bit. Another category of thing that I'm curious about is back-end registration, discovery, versioning, and packaging stuff. So, for example, how should a backend register itself with the system? Is it you have to import it explicitly as the user, and then it will register itself on import? Should it actually use a plugin mechanism so it can be discovered by SciPy or scikit-learn, or whoever can go as part of its initialization, go discover all of the installed plugins? That's one set of questions. And then the other one is versioning those backends. So suppose, say, scikit-image needs to change its backend interface at some point in the future, because the future is long and it will. How does that get communicated back to the backend so that the backend knows it needs to, in fact, it's not compatible anymore with the interface? And is that compatibility a blanket thing, or is it just function by function? And so you could still use it as long as you didn't use the one that changed. When does that error get communicated? Does it get communicated at import time, or when you hit it? So that's a whole gigantic can of worms. I don't know how people are thinking about that now.
Ivan, you kind of started a conversation around the registration part of this question, at least. So maybe you want to give an answer here?
I think we can implement anything we want, but it's difficult to decide what we actually want, like what kind of behavior we want. And I think the easiest thing to implement is to just tell kind of in the documentation of the main library to the backend implementers that you should conform with the API that we set. And if something changes, then you should do the changes accordingly. But if it doesn't happen, suppose like on NDImage changes some keyword argument and introduces a new one, and backend and uses as a backend that doesn't have this new keyword argument, I think what would happen, like with the current SciPy FFT system, for example, an error would be at the point when the user tries to use this new keyword argument and backend doesn't have it, and then it will just error out because unknown keyword is received. That's what should happen. Also, backend implementers could just accept any keyword and then pop only relevant to the function, then it would be ignored. So it's also a responsibility here on the backend implementers to treat the keywords carefully and not just accept everything and ignore all of them. It's unclear, but
yeah. Well, and a related sort of chicken and the egg problem here is the suppose everyone who knows that there is in fact an interface change happening at the back for, let's say scikit-image, that one of their backend interfaces is going to change, and all the backends know that they're going to have to update to it. There's the question of how do they roll out a new version of their backend package such that it continues to work with the old scikit-image that has the old interface and the new scikit-image which has the new interface. Is it a lot of very careful version constraints? Is there a way for them to detect when they're loaded that, oh, this is the particular version of scikit-image that there, so I need to implement, I have two, the old and the new implementation, I'm going to slot in the right one to the dispatch system, depending on which version of scikit-image I have, or something like that. There's the rollout problem where we don't want to have there be like a window of failure because you can't have everyone hit publish on PyPI at the same time. So it's just. It's not something obviously we can solve here, but it's one of the real key things I think for documenting how to use this and how to implement things is just telling people what's their playbook when this has to happen. What should everyone do in what order?
Mike?
Yeah, I was just going to add +1 to that, and that's one of the things that I was hoping with having the API defined in an abstract way, we could version that API, and so you could have the different backends explicitly state which versions of the standard API are they supporting, and then the sticky question then becomes how do we support multiple versions, and then what's the difference between supporting the API versus supporting the objects that are returned by the API, or is that the same API, or would we want to have the same function signatures, for example, be able to return multiple version types? I don't recommend that. That would be painful, but that's the sort of like conversation you start to have, right?
Yeah. So I think this, I'm fairly confident I have a reasonable answer to. This is actually the easier part of what Stan asked. The part about discovering backends and should they enabled automatically, or is there a switch and who controls the switch? That's the harder part. The, changing APIs, if you look at how we change APIs in a library like SciPy or scikit-learn, the vast majority of changes are backwards compatible extensions to existing APIs, right? Typically adding keywords. This should actually be supported completely unchanged and should only, if a backend doesn't have the new keyword yet, but the user didn't specify it, which will be, pretty much all cases, they go with the default, right? That should not break, right? The second part is if the user does specify, well, here's a new keyword and I want this non-default option, right? I think then you want to clear error back. The other part is, every release typically contains a couple of backwards incompatible changes. I don't think much changes there from what we do today. It's very rare that behavior changes without, the signature changing. That's a big no-no for any library already, right? So typically it's, introduce a new API, deprecate the old API. And I think that's the thing you probably should solve with versioning. But I think as Stan sketched already, switched on the version of the library itself, right? So up until version, 1.10, use this backend, from 1.11, use this backend. So I think, this is something we should write down much more carefully because it's extremely important. I mean, we all have lots of bike shedding about deprecations and backwards incompatible changes, especially. But I think this is fairly well under control.
And that's my concern. I think it's probably fairly well under control today with SciPy, but as soon as in NumPy, between SciPy and NumPy, then as soon as you start having other alternative backends that are being implemented that are meant to work with this API, you may have other communities, other conventions that may not play nicely with that, and so that's my concern.
Benjamin?
Sorry, if you were going to say something, Ralph, in response, I can wait a second.
Yeah, I just wonder why, because what the concern is from Mike, because the users and the higher level packages will call the SciPy and scikit-learn APIs, right? So those are the ones that are going to change or not. And I think all these projects are extremely conservative in terms of backwards compatibility compared to, faster moving ecosystems. Like, if you look at a deep learning library, they're much more aggressive in deprecating and removing functionality. But I think in the end, there's only one library controlling the evolution of the API, of each API. And I think what would be a good change from my perspective is like if, let's say, NumPy or Dask or a PyTorch wants to see changes in SciPy or scikit-learn, right, that they actually get involved and have that conversation rather than, well, we cloned this API, but now we don't like it anymore. We just changed it. And now we have two subtly incompatible versions floating around in the ecosystem. But I think it's then like, if you want to change the SciPy API, you show up on the SciPy issue tracker, you make a proposal there and you have the conversation. That's at least how I would hope it would happen.
Benjamin?
Yeah, I wanted to ask if this group thought, sorry, let me first state, I think that as a user, or the users that I deal with, they don't know what is supported. And we're talking about building something that is going to kind of magically just work. It would be really great if we also built some tooling for authors, for developers of backend libraries to say, this is how much of the API we support, or some way of informing the user before they hit go. A concrete example of this is 𝗗𝗲𝗃𝗃𝗃𝗃𝗃 is rather sparsely supported, or 𝗗𝗲𝑃 scipy stats. And I don't know that it's sparsely supported until I'm in a big, painful mess. If there's, it's probably not formally part of this, but it's unclear as to whose job it is to inform users what should be happening. But it'd be really great if we built some tooling. I think that solves this problem for, like, cuDF, we deal with this all the time. We still don't have good ways of telling users how much of pandas we support. And
yeah, that's a really great point. I totally get it. And it's something I hadn't considered yet, but I think we should consider building that tooling indeed. And probably as some standalone code, maybe as a Sphinx extension. Like, we have to think about what that would actually look like, right? But it should be, ideally generate easy to understand tables in docs or some such thing. I think NumPy actually has the same problem as well. And I've always looked at, like, when NumPy adds something or changes something, how do you see what NumPy supports? Do you have any thoughts on that, Stan?
It's currently a giant handwritten document that is annoying to keep up to date. So I don't know that we have any other tool. I don't know, Sud, is there any other stuff?
Yeah, we do have, since everything that we support has to register in the type system, so we can query the type system, which is one big giant database, and our documentation is automatically generated. So you can go to the NumPy and type in numpy.sum, and it will actually point you to, if it is implemented, it will point you to the code. It will point to a section that points to where it is implemented. And we have a similar runtime thing that you can query. Like, we call it the inspector of something. Yeah, there's a number.help, and then you can ask if a NumPy function is implemented and where it is implemented.
Yeah, it will be useful to have a tracing thing as well to see live when you're executing which backends are getting hit and have output to the user.
I was wondering how much of a hassle this actually was for Dask and array function, because they have this problem. If NumPy changes, they have to catch up, and it's even worse because they have no tooling at all. They just have to catch up as soon as it happens. I find these questions super important here, in the sense that I feel that library authors have to basically say what they want and what they expect of any backend system that is proposed. So if we need to create, for example, we need to create this coverage list. Do library authors, there was one thought I was wondering about, if the library knows that the backend was written for 2 versions ago, they might be able to say, look, this function just doesn't work anymore the same way, so you can't use it at all. So they might be able to just reject registration of that function if they know it's not compatible anymore. Do we want hooks like that? Is it important? How much control do libraries need about the API, about the backends that get registered?
Neil?
Yeah, I wanted to follow up with this discussion because I think Greg just posted 𝗂𝗲𝗃𝗀𝗃𝗀𝗃's comparison table in the chat, and I think it's very valuable to some degree, but it's not. Sometimes I feel it's deceiving because you can look at the hey, NumPy has this function and 𝗂𝗲𝗃 also has it, but actually the supported signature is different. Maybe we miss some arguments, or there is a keyword argument that supports 5 different options, but we only support 3 of them. You couldn't tell them from looking at this table at all. And I think that Mike and others also had discussion internally about this tooling stuff, related issues. And generally, my personal feeling is I would prefer to have some kind of test suite, like Sebastian was saying, maybe we actually run it and then generate some kind of compliance charts or something like that, instead of just listing them out, because it's just not covering the entire picture of this support.
Yeah, I think that, you know, which positional and keyword arguments are supported, you can do just from the registration, right? That, you know, the information is just in the backend. But if keywords take multiple options and you only support a few of them, I think, yeah, that there's no way around actually running code and tracing whether something works or not.
And that's actually what happens in scipy, right? In all these algorithms, they keep adding new keyword arguments, but the argument is the signature is the same. But there is no way for us to automatically figure out that in the new versions of scipy coming out, and there is an additional algorithm being supported through keyword arguments. We really literally have to go through all the release notes. It's just it's really very hard to catch up. Yeah, I would say.
Yep. Go ahead. I'm gonna try to say your name. Could you say your name for me, please?
Sue.
Sue?
Yeah, that works.
So, sorry about that.
Yeah. I'm just wondering if it's even possible for the interface provider, the API provider, to make their test shareable. As like an implementer would then just run the same test, and then it would expose us whether something new is supported, something like that.
Sebastian?
I was just thinking that I feel it should be possible. I feel it should be possible for you to basically create a fake backend, and maybe the backend provider has to do some work there, but create a fake backend that acts as if the input was a NumPy array, say. So if the original library only works on NumPy arrays, you could plug in a backend that converts the NumPy input into that, does the calculation, converts it back at the end, and then runs the test suite normally, just that every time where the NumPy, where the default one should be used, you inject yours, you replace it with your backend that you want to test. I feel it should be possible, but you need some conversion logic that is custom and specific to the testing process, probably.
Benjamin?
Sorry, along these lines, does scipy, the community and the scikits, will they be the arbiters of whether you can publicly decide to announce something is supported? So can I go, is it up to, can I go out and build an array library, claim that I support everything, and really I only support just like 3 things or 2 things? Or are we interested?
I would hope scipy and scikit-learn, scikit-image do not become the arbiter of such things. I hope that it's a generic backend, and, you know, anyone is like, just like today, anyone's free to make any claim they want, right? We hope that everyone's honest and realistic in their assessments. But in the end, I think, you know, it's not like we have like 2 or 3 other array libraries and that's the end of it. there's new ones being created all the time. So like, 𝗗𝗲𝘃𝗃𝗃 was just announced a few months ago, right? And like, well, it was open source before, but it was like really like not very visible. And all of a sudden, like, I guess it's starting to become a bigger thing. It should be possible to develop something like that, or even completely in private and then open source it later. Or, maybe if you're a large company, you want to have such an internal thing. I've actually seen internal tensor and data frame libraries that were never open sourced. I think that should be possible. And I don't think, at least I, as a scipy maintainer, wouldn't want to have any say in that. Like, other than like, if I see a misleading claim, asking like, can you please not do that?
Thanks. I appreciate that clarification.
Yeah, we get a couple of scikit-image devs here as well. Like, does anyone feel different?
I think that seems reasonable to me. I don't think we can, say either implement everything or implement nothing. That's not reasonable. That would be a huge amount of work to have everything provided exactly the same by all backends. But it may not even be feasible with the same algorithm on different hardware. So, yeah.
Benjamin, did you retrain? I'm sorry.
I would say like the tooling we just discussed, like it would, I think, make sense that would live under, maybe the scipy or the NumPy organization somewhere, so that it's like central and easy to find. And like, this is the recommended way of generating these comparison tables, etc. Maybe you can all use them and say like overall coverage X%, etc. So, but not as an obligation, more as recommendations and helpful tooling.
I mean, it also might make sense to put it on the scientific Python.org site as a central place to have things. But I also think the idea that it would not be an enforced mechanism, but of a place that users could come and get a query of what's the status, or get developers could get resources. But yeah. Do anyone else have any comments on the that?
Did you mean the tooling, or did you also want to host like anyone who wants to put up their own comparison table, like be scientific-python.org be the central place for that?
I feel like there should be one comparison table, maybe for this project, right? I don't know. I mean, how many? Because it would be nice if your user to be like, I want to like know all the packages that support these things. And then instead of having to go to like each package and be like, what things do you support? And the tooling can there, or it can be pointed to somewhere else.
I think maybe you want both. I think I'd expect each project to still want this information in their own docs, but yeah, it'd be great to have a central table. I think if it's kept up to date. So we have to, each time everyone does a release, it kind of needs a new upload there, right? So it is an extra step, but should be feasible.
Yeah. Especially if you end up having like the CI thing that we're talking about at some point.
Yeah, and we can host that data as a rendered table and like the JSON as well, so people can just grab the JSON and render it inside their docs if they want, whatever makes sense.
So I suggest, since there's a pause here, and you can say no, but I noticed, Stefan, you made some comments in the window, and I don't know if that's captured in my recording. So is there anything from that you wanted to mention, or it's all been discussed?
I don't think anything that wasn't covered. I was just thinking about, when you call the function in scikit-image, then that will be the entry point for the user. So ultimately, the package being called has control at that point. And I think that, that's why it's important that we come to a general agreement on what will be implemented by the library, so that there's a standard mechanism that's experienced by the users. We don't want all the different libraries to try different ways of handling this. And then, maybe I'll just comment on the whether backend should implement everything or nothing. I've always thought it would be best if backends had complete freedom in what they provide and don't provide. And then, yeah, as long as we can advertise that. But specifically, I think it's important to allow the entire public API to be overridden. Like the library shouldn't basically choose, oh, we only want, you know, these specific submodules to be re-implemented. But of course, you have private API that you can hide. That's perfectly fine. I think that's it.
Yeah, I think we already had an interesting discussion about that, Stefan. I think I agree with you in principle. I would say like the API of like any of these packages are really large, especially SciPy. I think, you know, maybe even have like 3,000 objects. Clearly that's not going to be done like next year or even 2 years or 3 years from now, right? So there are modules that are more important, that are less important. And I would say we should do it per module, start with the most obvious one, like, you know, Linux clearly is more important than IO or MISC. And the other disclaimer I would make is like, yeah, everything should be overridable unless there's a good reason not to, right? Like if you know, like, well, actually there's a maintainer who wants to go rewrite this thing from scratch. It's like, let's just say that, open an issue and say like, well, we need this prerequisite. Let's do the rewrite first and then add it to be overridable. Do not cause more problems than we solve.
My hope was that the mechanism that the hooks that we implement would be lightweight enough that it's fairly easy to, you know, allow the whole library to be overridden. We haven't discussed much what exactly those hooks would look like. But again, in the back of my mind, it's for tracking execution and making visible to the user, you know, what their entire execution pipeline looks like. So hopefully not too much work on our side, but of course, you know, we have to give ourselves time to do it. Stan, sorry, you've got.
Well, yeah, so as I say, we're also looking at this from the perspective of retrofitting this onto existing libraries. I can imagine a future where this is commonplace. Someone could actually design a new library from scratch where their user interface and their backend interface are actually entirely distinct, and say, okay, I'm planning for a hardware diverse future. Hardware makers, I want you to do this part, and not necessarily always have to stick it directly onto the user-facing API. So right now, though, I mean, a lot of cases, because these libraries are so core in the stack, they are the internal implementation of things above them. It makes sense for SciPy and scikit-image and scikit-learn to get as much of that public-facing API overridable as possible. But I can imagine downstream other libraries actually making a very clear distinction between interface and backend, or user interface and backend.
Even in SciPy, that makes sense to some extent, right? Like if you look at stats, there's a whole bunch of functions that are like, well, here's 50 lines of Python code. And then at the end, there's like, you know, a function to some really obscure scipy.special function. And, you know, as a user, you're going to call the top level stats code. As a developer, like, do you want to, you know, copy everything, or do you want to take the Python as is and only overwrite the scipy.special? And it's not clear there what the trade-offs is.
Do you see any dispatching between the libraries? Like maybe between, having trouble thinking of an example, but something that's implemented in scikit-image and scipy.ndimage. Is that, how does that work?
I would say yes. Thomas Fan has already been looking at scikit-learn, and it looks like it has a fairly heavy dependence on optimize.minimize. So there's a whole bunch of code that is Python, it's reusable, but it would need optimize.minimize to be reusable. So I guess it would call SciPy, and a SciPy would dispatch out. That's the thing you meant, right? Yeah, so there should be things like that, I think. And the same for scikit-image. It relies very heavily on scipy.ndimage. So that should be dispatchable that way as well.
So what I'm trying to understand what is meant here. So would it mean that if a function calls, if a scikit-image function calls NDImage, that you can override both, or?
So I think what I meant is if you have a function that's pure Python in scikit-image, right? But it calls scipy.ndimage, which contains compiled C code, right? You can have a, let's say, 𝗗𝗲 array, just go all the way through the the scikit-image pure Python code, hit the scipy.ndimage call, and then it gets dispatched back to 𝗗𝗲𝑥.scipy.
Yeah, so I think again that I think we have two very distinct cases that we're discussing, and the one is this one of array dispatching, and the other one is of overriding the full API. Because if you override the entire function, then this isn't a concern that comes up. I think the array dispatching is where all the hairy questions come up about exactly how you dispatch in different places. And I think that's also one of the things we should clarify today is whether that option is feasible. That seems to be where the hardest technical challenges lie.
I think that part is feasible. To me, the hardest technical challenge is a third class. That's the example where it's mostly pure Python and then a direct compiled function call to some internals. Let's say, you have some private Python thing to accelerate something, right? And then do you say well, do I need the backend? Do I do what Stan just said and have a separate, backend API for just that little private thing that's in Python? Or do I say, well, there's some compiled code here, you have to just take the top level function and re-implement everything. I think that's a pretty fundamental decision that could go either way.
Yeah, because also for the library maintainers, the burden will be, I think that there'll be a heavier burden if we decide to go with with supporting the various array objects, just because it affects code at multiple levels, like you say. Whereas providing just a mechanism for overriding a function is quite straightforward.
But those two things don't necessarily, they don't collide necessarily, right? You could anticipate that you have a type dispatching so that a 𝗗𝗲 array goes, the 𝗗𝗲 can override the scikit-image function. But you could also say that for certain simple functions, you have a duck-typed backend that can always handle everything so long, I don't know, the function it uses inside are also correctly duck-typed, overridden, like the function, if it uses function from scikit, from scipy or so.
Even if you just override, the functions at the top level, then the backend could build in dispatching of whichever kind it wants. I guess what we're aiming for is, if we're going to do dispatching, to have it be more general, so that each backend doesn't have to deal with it.
Well, but at some point, I agree with Sebastian, you can have both, they don't conflict. But I think at some point you're going to a place where there'll be packages with only pure Python code, right? And at some point you got to stop duplicating those. So I think my rule of thumb was, if any function is completely pure Python, ideally you want to use the array API standard and you want to reuse that Python code rather than having every backend just duplicating the Python code. Because you can say well, as a scikit-image dev, I want to retain a maximum freedom to change this pure Python code or, to convert it to compiled code later. And those are important questions. But I think, what about the level on top, right? They're also pure Python. In the end, everything above this level is either pure Python or pure Python with a bit of Python. And where do we start reusing that?
So are the mechanisms currently in NumPy not sufficient for supporting that use case?
Well, that is the array API standard, which we just merged in NumPy 122. if you're asking array function and array ufunc, no, I think they're totally insufficient.
Well, something needs to do the dispatching still. So that's what I'm asking about. Is this something that NumPy can handle? Because we can already support pure Python code paths at the moment.
Yeah, I think that there's a design pattern for using the array API standard, and then every other library that implements that will work. The problem with using just NumPy function call is that, like, basically NumPy has like a very, very large API surface, and there's no other library that implements that. So you have zero guarantees. And I think to be able to reuse Python code, you have to have such guarantees.
Yeah, I think that's very reasonable to limit the NumPy API. I'm just curious, what would you call? Would you currently call the array API within NumPy, and then things will just work?
That's the idea. And so it's a limited API, something like 140 functions. Almost no more complex objects, like no like ND array dot flags or dot strides or something. So, and there's a completely portable test suite that can be run against the different array libraries. So if they pass that, then things should work. Of course, that they're still to be proven, but right now that test suite's already run on NumPy and on CuPy. And I guess there's more work to do and make the reporting better. Is like, hey, which parts are not yet implemented correctly. But I think the fundamentals to do it this way are there.
I think that's great. Yeah. So if we combine that array API with a dispatch on function level, we can deal with both these cases. And we wouldn't need to. I mean, we can always later on go and see how deep in the stack we want to, support this with Python code and so on. But we could punt on that for now, and already support most of the use cases we have in mind.
I think I wanted to add that having scikit-learn as the API sounds like very exciting as well. I think there's lots of users that have wanted to do GPU things on scikit-learn, and having that be able to dispatch to any number of PyTorch things or cuML or TensorFlow would be really cool, rather than trying to shoehorn in CuPy into things that wouldn't be performant, or like you said, the Cython parts of scikit-learn would be extremely challenging.
That's actually
Leo? Sorry, Ralph, and then Leo.
Oh, sorry. I was just going to say that's actually great to hear, Ben, because I know, like, you guys at NVIDIA already have cuML, so I was not completely sure if you wanted people just use the import or you actually are happy with the dispatcher. So I'm glad you're happy.
Yeah, Leo.
I wanted to kind of ask a parallel question, but so far we are discussing dispatching at the Python layer. So meaning that we use array API standard to dispatch. So and all the downstream libraries we use to just use array API APIs. So what's the implication for us as vendors? For example, NVIDIA, we provide math libraries, we provide different low-level implementation that targets our hardware, right? So is there a dispatch mechanism? Maybe, for example, in the end, TensorFlow, PyTorch, and the CuPy, they all call some cuSolver functions. Is there a dispatch mechanism that allows those higher up libraries to, in the end, try to do the same thing to dispatch? I mean, I don't know if this is a valid question. I'm thinking more instead of now. I'm thinking instead of on the Python side, I'm thinking on the compile code side. So if we provide compiled code, we provide libraries targeting particular hardware. What's the implication for us? Is there a standard, or is there too early for us to talk about this layer?
I suspect it's a bit, or I mean, when you say things like 𝗗𝗃𝗃𝗃𝗃, and that would be like a generic API that can be dispatched to, I mean, that's more like, you know, the BLAS or laidback idea, right? And now it's like, well, we have other Python code inside, let's say, you know, somewhere deep underneath some scikit-learn.fit functionality. Do you turn that into a BLAS like, well, anyone can implement this thing? I think it may go there, but I think that's the thing that Stefan said, like, let's punt on that, because that's probably like right now one step too far.
Yeah.
Stan? Good.
Yeah, I was going to say, definitely. I think we want to keep that out of scope for now, because the mechanisms we would use to do that would be so different than the Python side. Just the implementation would be an entirely different universe of things. So I think it would be that if there are things like that, there may be some redundant code at the Python layer, so that all calls down to the same C libraries or something like that. But that, I think we'll have to live with that for now. I think that'd be fine.
Yeah, I would. I would agree that this seems more like a problem that we can solve later, unless you want to have on the Python side a backend that says, I support any of these GPU libraries already, which might be nice, but doesn't seem necessary as such.
I think this nicely fits to the example that Ralph mentioned, that if you have lots of Python code and then the small part direct call to the compile part of the code, and do we want to like allow backend implementers to dispatch on that or not? And maybe in some cases it can be allowed if it makes the life easier, but then it's difficult to determine the cases. For example, in this 𝗗𝗃𝗃𝗃𝗃 and lapak, scipy has scipy.linalg.lapak to be used for someone. It could be hidden, and it's not clear whether it's a good idea to allow dispatching on that. But for example, what I know for sure in Julia, they also have lapak namespace, and because in Julia you can dispatch on any function that exists in the base, what CUDA library of Julia does, they actually dispatch on this lapak call to 𝗗𝗃𝗃𝗃𝗃, and so once they do that, they have this higher level implementations of functions that depend on this function working automatically, and then the part the library of responsibility who develops the CUDA part is only to overload this lapak low-level function to make it work.
So it sounds like there should be a glue layer that unifies this interface and then internally dispatch to different libraries, if there is one.
Yes.
Yeah. I mean, I can imagine we go here with, for some cases in the future, for the example of scipy.linalg.lapak, those are basically just raw F2Py wrappers of lapak, you know, with no design whatsoever. So I would hope we would never include that. And I hope that very few people are actually using that, because it's never really designed to be public, I think, to begin with.
Unfortunately, it's being used in scikit-learn, for example. I saw the uses of BLAS directly instead of NumPy.
Another example is FFT, right? Yeah, you have cuFFT, you have VKFFT, you have CLFFT, and FFTW, of course, which are all heavily used by the image community. So there's something interesting to me.
You talk about using it at the C level, because at the Python level we already have a dispatching there, right?
Right.
Yeah, so Sebastian just raised a question that I was kind of starting to think about as well. So we have about 20 minutes left of the scheduled meeting, and we don't want to break this, but Sebastian was wondering if we should start thinking about next steps, or maybe we should just take a moment to think about what we want to do the last 20 minutes. Any thoughts?
next step sounds great to me. Should I say something? So I think one of the questions we have, there are already some good ideas here, like actual things like, hey, you should build some Sphinx tooling, things about, making test cases reusable. So that's actual work. I think the other part is kind of what are we what, if anything, are we going to write to kind of describe this design better? Should it be one or more design documents? Should it be like a whole, a Sphinx doc that goes through all of the questions that we ask now, like, hey, how do we evolve an API? How do we release new versions, etc. So love to hear some opinions on that. And the other part is, sorry, one more thing. The other part is like, we have to actually write a whole bunch of code. Some of it has to live in PRs to SciPy, scikit-learn, scikit-image that are not going to be merged yet. I think we hope to get something merged, like, in Q1 next year, because we have, there's actually some code already waiting, like scipy.ndimage has had a backend waiting for the past 4 months or so, and it's basically complete and reviewed. So I'm sure there's more like detailed discussion there. But I guess maybe, we have an idea in mind that I'm not sure we described well enough about what the state of this project should be by, let's say, the end of Q1. And then there's there's probably to do everything in all of these 3 packages. There's we are another 1 to 1.5 years ahead. And then, we're having multiple people from 𝗗𝗲𝗃, from DAS, from whomever, that actually want to start build their own backend. So maybe we need some sort of more collaborative long-term plan there. And I haven't given that a whole lot of thought just yet. So
I just make some very abstract, general logistical comments, and then Stefan can fill in some more details. So I think this would make a lot of sense as one of these specs. The spec documents themselves should be very high level and abstract, and give you the big picture, but not the details. So I think that it'd be nice to get a spec started with, almost some of the content we already have from the blog post or something, maybe a little bit sparser than that. And then, that document would point to maybe another repository, which we're happy, I think, probably to host on Scientific Python. We could give it a, I don't know, some kind of raise.scientificpython.org or something. And we can help set up some of that infrastructure to make that as seamless as possible. But that's just a very abstract, high level. So Stefan, do you want to maybe have some more concrete?
Yeah, I think it'd be good if we could come up with a set of principles, sort of a minimal set of principles that will guide the effort. We need A, B, and C implemented in order for this to work before we make any technology decisions, because we tend to get bogged down in those discussions quite quickly. And with principles, I mean things like, are we going to, as an initial version, are we just going to allow, overrides on the function level plus the array API? Is that satisfactory? We require docs with tables. So we make a list of that. And then I think we can discuss later what specifically we want the implementation to look like, because I know, once we start talking about UArray and that sort of thing, there's conflicting opinions of how we should do it. But as long as we all implement the same principle, and hopefully we'll use the same code to do that, I think that'd be a good start.
I think that principle thing would be really what I'm imagining the spec document itself being. And it can start out, we can merge it with fairly it's not, we won't be endorsed, it'll be a draft when it first goes up, so it'll be on the website, get more attention, and then we can refine it. So it doesn't have to be finalized when it goes live. It just has to be a reasonable starting place.
Yeah, I have to say, I don't think this one spec in itself is going to add very much, because it will contain less information than the blog post plus the initial forum post that we already had. So I'm thinking like if a lot of the questions that were raised in this meeting, we're going to need significantly more than one document.
Yeah, so again, like part of the spec idea is there's a place where everyone can go to find something instead of having to be like, what blog do I go to or what place, right? So, and then that would point to some other place where you'd have all the detailed things. I mean, it doesn't have to be, I mean, yeah.
Okay, so this would be the boil down what we already have and then use it as an umbrella and link out.
Yeah, exactly. Yeah. Like, it shouldn't be a lot of extra work at this point, I think. I mean, it seems very close for that document, but it can get revised, I think.
Yeah, it should be easy for people to get into the conversation. And, you know, even with the current threads we've got going, there's like a lot of reading to do. So we should just keep dynamically summarizing the current state of our thinking and have that in summarized form so people can follow along easily.
And what kind of documents would you like? I mean, would you want to, for putting this more detailed documentation, I guess it'd be nice to have a markdown thing that generates web pages, or what would you like to see?
Sphinx is our go-to tool, I guess. It's just, you know, what color is the bike shed? What theme do we use?
Yeah. So the other thing, we've been using Hugo, and there's also like the, you know, the notebook kind of document, or I don't know where all that stuff is, but yeah, whatever you guys want, we can put up.
Yeah, we actually like experimented starting with just Markdown and Mist in the Array API docs, but we figured like it's actually like a little nicer to write Markdown when you do narrative, but as soon as you add in function signatures and more detailed stuff, like you figure out the rest is better anyway. It has more features, and in the end, it's nice to put things in Python code so that it can be reused and then use out the summary to feed it into Sphinx. So I suspect that's still the most mature thing and the most useful thing here.
Sounds good. Yeah, so I guess for next steps, I will go ahead and then create a repo on the scipy.ndimage site. If I'll give a name, we can change the name later. And then I'll make that a Sphinx repository that we'll generate, and then we'll make a, I don't know, arrays.scipy.ndimage or something, or whatever. But yeah, I'll try to coordinate that with Ross and Stefan and loop you in, Ralph, and you can just change names or whatever. We don't care. Sebastian?
Yeah, it was so for me personally, I'm not in the state yet to make a decision on a concrete proposal like you, Ray. So for me personally, I have so what I currently see is I see this great vision document, the vision outline of what we want to get and where we want to go from the user's perspective. What for me is missing right now is some of the points that we have laid out also today, like what do we expect from the dispatching system to provide, like this table of functions that get covered and things like that. So I personally feel it would be very helpful to maybe write a specific document about that and then use that to decide on the concrete implementation. I don't know how you see that, if you completely disagree with this, but I feel like we need to go through this step to really settle down on what to start off as a concrete implementation.
I kind of like the idea, and I think it's more productive than forum threads, because I feel a lot of that is very verbose and almost like, you know, half of it is misunderstanding and then someone else jumping in with like, you know, a change of direction or a misleading question. Or I suspect writing a formal spec specifically around that, and maybe also in the, you know, explicit, like, here's the question, what's the answer, in an FAQ kind of format may be very useful.
Leo?
A related question. I'm just curious. I know what we are doing, we are proposing, we're planning here. It's very cool. It sounds very useful, but just how useful it is. Do we have an estimation, like what's the potential user base, or what will be the targeting community, or even laboratories, university, research institutes, companies, etc. Do we have a like head count, or for sure, are we sure that some part of the community will be surely on board with this? Yeah, I'm just trying to get some numbers out of this, like potential impacts of this.
I suspect, I mean, we're of course trying to design for like distributed, lazy, meta, etc. But I think the single main use case is still just GPUs, people with GPUs. Majority have NVIDIA GPUs. I think right now, part of the issue is that like they may have to do a lot of manual switching because everyone starts developing on CPU. And I think that this number is growing. I don't know, rough, like my just gut feel, I don't have hard numbers, is maybe 5% of the total user base of these packages, which is, I think, rough estimate, 20, 25 million people.
Stan?
Yeah, I was going to say, I mean, the way I would think about approaching this is anyone using, 𝗏𝗃, I mean, there's sort of an existing user base of functionality where this is being solved a different way that's maybe not, a little clunky and whatever. So like another thing to mention is it's not just GPUs, but also optimized CPU implementations. Intel has been kind of, trying to figure out where to put. They have all these optimized implementations of different common algorithms, and they've been trying to figure out where should they put them to get them so that users can use them. And so anyone who is currently using, like, for example, the scikit-learn extension that's optimized for the CPU, all of those users would probably benefit from this because that system should probably migrate to this new one. Stuff like that. So there's, there are probably some packages we could identify and just look at download counts to get a sense of today how much of that's happening. That's not to say then there's a whole separate set of users who aren't benefiting from this because they don't know or it's a little too clunky. That's a little harder to estimate. I would defer to Ralph's hand waving is probably as good as anything.
Well, my expectation is, because I've seen like the Intel things, like they've been at it for quite a while. They seem to be, very capable of writing faster algorithms and not super capable in getting people to actually install these packages. Like, I think the download numbers will be low. So I think this will actually, clearly, like, on the order of half of everyone, maybe more, has an Intel CPU. I think if they really are like, very straightforward, everything still works, but now it's faster. I think that's, half of the user base of scikit-learn will want a faster scikit-learn. But I think the user base of the Intel optimized version is maybe, a few percent. I'd be very surprised if it's more than 10%.
Yep.
Be happy with these next steps. Anything else, Jared, Stefan?
So that sounds good to me.
Should we plan a tentative follow-up meeting or something?
Yeah, I think there may be other people who want to join. I think this was actually super useful to get everyone's ideas and feedback. And I think having this uploaded and having other people watch it may be more accessible than the forum posts. So I think if we do this again, we should probably do it with a broader audience or an open call rather than, a set of invitees to get things going. That sounds good to me. Mid-January or something like that.
And I think we're also happy to give a hand with writing and refining the spec.
Yeah, I was thinking about giving some rough thing, because I mean, you guys already have the document there, so I think I could just create some notes or something, or just copy it. But yes, I'll probably do the PR and have you look at it or something, around just to share the work.
That sounds awesome. Thank you.